an eye towards time here, I want to talk to you about a couple of things. One is peer reviews. So we've used peer reviews in my group for models to very good effect. So the idea was a peer review, folks. For those of you who are not familiar with it, this is not about reviewing peers. It's about reviewing artifacts, several peers coming together and reviewing an artifact. And the goal is to keep the attention on the artifact. It is not to find out who is to blame so much as to learn from the artifact about what we could do better, what things may need to be fixed in the artifact, what things may need to be fixed in the process. Reviews are one of these things which is viewed as an industry best practice in software development. It's actually more cost-effective than testing. It can find more bugs and can find them in less human time per bug. It tends to easily pay for itself in formal studies when inspections, a formal type of peer review, are done. And it's actually more flexible than testing, because you could review for a model, folks. Well, tell me some things. What could you review for a model? So obviously, I could give you a certain model and say, could you look at this and comment on it? And that's really useful. And if we got together a group of us and we said, okay, Molly, you're the presenter, Dylan, you're the reader, and Shin, you're another reader, and Steve, you're the moderator, and Yue, you're the recorder. We could do that, and that would be closer to a formal inspection, although there's some other elements of that. But what sort of things besides a final model might be reviewed usefully in a modeling project? Besides, the actual model that comes out from the process. What things could be reviewed? Particularly what things could be reviewed earlier in the process?
The way it's structured and how efficiently you've created your variables.
Yeah. So early on, you might have identified who are the major agents, right? And someone could comment on that and say, well, I see that you have persons, but you don't want to represent health personnel also? Or, do you really need to represent 5 different types of agents? Couldn't you do it with 3 and treat, 2 of them as more or less, or, 3 of them as more or less variations of the same thing? So you could do that. You could we can draw out state charts without having parameterized them. We can just draw them out, use them to illustrate what we're thinking in terms of the division of states someone could be in. That's a useful thing you could review early. You could review a scope document. What are the 3 big sort of divisions in terms of scope that I mentioned early on in this class for a model? When you're thinking about a model and you think about whether some phenomenon is going to be in the model, what are the 3 possible ways that you could answer? It is endogenous. It's simulated in the model. Those dynamics are captured by model mechanisms. And that's powerful because that means if we change parameters, we can see changes in this thing. That's the most powerful way. But another way is it can be exogenous. It's still in the model. It's in the model in a fixed way with a fixed set of assumptions. Maybe exogenously, we assume some economic, downturn and upswing, or we investigate several of different ones of those. Those would be exogenous. We're not calculating that. We're just imposing those assumptions. Finally, it can be explicitly and consciously ignored. We thought about it. We decided we don't want to put in the model yet. We're not convinced it's required, or at this stage, we don't want to have to worry about it, the complexity. We're trying to learn one step at a time. So we leave it out of the model consciously for now. We don't represent it at all. We could review a document of that sort and reflect on it and say, well, is this appropriate, or do we really need this thing at least exogenously represented? That would be something that's useful to do. And that would be something a peer review could be used to do. It could review test documents. It could review, plans in terms of schedule. It could review interactions between agents without looking at the code, sort of a description of these things early on, before code is ever written. For Venn models, good, or review the breakdown in terms of subscripts and what you're planning to incorporate. So it turns out early reviews have a disproportionate benefit. Doing reviews early in the process buys you a lot. It allows you, for example, to avoid whole rat's nests of issues, going down rat holes, and instead steers you clear of some troubles. Early artifacts have a disproportionate process. And this can include, well, in general software, it might include a lot of additional features, but a lot of these apply even here. And there's benefits to peer reviews to go well without the model. Imagine you do a peer review and everyone forgets. UA's notes as recorder of what comes out of the peer review are burnt up. They're suppose they're destroyed for some reason. Suppose that all people forget what went on in terms of actual bugs found in the artifact. There's still been learning about the process. Clarifies understanding of how AnyLogic works, how clever ways to do things within AnyLogic, stylistic ideas, how to represent things clearly visually, how to color things. Some of the most beautiful models I've seen have been literally beautiful. People take model things like state charts, and they lay them out really clearly, and they color them in a really compelling, consistent way, and that adds to our understanding. It adds to our memory of how to navigate the model, where things are found, etc. And these are the sort of things you might learn from a peer review. The person whose artifact is being reviewed learns how to improve their technique and process, and it leads to a spread of knowledge more generally. There's a lot of guidelines for reviews that I don't have time to cover here, but these will be in the slides. These are from Carl Wiegers. Wiegers' great book on peer reviews. And what you'll find is there's a formal type of review called inspections. And inspections have a set of stages associated with them that begin with a preparation stage. Even before that, there's a planning stage. So people review material on their own before the meeting. Moderators assigned up front. People assigned on roles. There's people invited, and there may be an overview given of the artifact, and people reviewing a formal inspection package ahead of time, and then they come to the meeting. And inspection summary reports, issues logs are created. Dylan has noted the therapeutic value of towel folding. The issue here is that the models have a real need to keep it impersonal, and this is a challenge because you're often describing things you put your full efforts into, and a lot of issues come up with them. Mistakes, oversights, inelegant things. And if you can keep it impersonal, that's often a key to having it work successfully and having learning really go more than skin deep. So within a review, there are tricks that can be used to kind of keep the focus on the model and help lower the risk of it being a stressful affair for everyone. And I think actually the towel fold is a very interesting one. It doesn't have to be towel fold. It could be some other activity that goes on during it that provides an alternative to sort of just worrying on the part of the person whose products are being inspected. So there's a set of stages. What's notable here is that there's a rework stage where items are actually fixed, and then they are updated, and there's a follow-up. Often the moderator would decide, okay, have the changes in fact been made, and confirmed in terms of the shared repository. Say the model has it been updated properly and so on. Finally, there's an element of causal analysis that uses the inspection process to try to figure out what was the root cause of this defect. Do we need to have more training that goes on within our group? Was there miscommunication between people? Are we pushing people too hard? Is there too much reuse of older models for their structure? Should we be creating things more from scratch, or vice versa? Do we need to have more peer reviews to catch things earlier? Do we need to do more testing? These are elements that can come out of the inspection process that relate to the process side of things. Okay, maybe I'll just mention a couple things on the technical related things here. How many people here have used assertions before? Okay, some people. So what's an assertion? An assertion is a sort of sanity check, a statement of your assumptions that serves as a sanity check that what you're assuming is the case is indeed the case. So when we build a model, and I don't care if it's in Vensim or AnyLogic or some other platform, we're making assumptions typically. When we write an expression as simple as prevalence is the number of infected people divided by the total population, we're making an assumption. What's that assumption we're making there, for example? If I write fractional prevalence is number of infected people divided by the size of the total population, I'm assuming that. Okay, that's true. So I'm assuming the infectives are part of that population, right? That they're a subcomponent of the entire population. And I've had bugs before in my own models, I think, at least some model, and I think it was my own, where I've had A divided by B, and I think A is part of B, but it turns out it's not. I forgot to add it into B. And so sometimes I get things where that appears greater than 1. And I say, how could that possibly be? I just forgot to add it into the denominator. Another thing I may be assuming is the total population is not 0. And it's not going to work if the total population is 0. So we're making, when we write our code, when we write our formula, or we write our Java code, we're making assumptions all the time. And the goal with assertions is to explicitly document our assumptions, but more than that, to make sure that they are operationally checked, at least when the code is still in development, that every time we run it, they're checked, such that those assumptions, if they are questionable, or if they are false, if they are misguided, will be alerted to that as soon as possible. Because if we have made an assumption that is not grounded, that is not true, we want to know about it as soon as possible to fail early. We want to fail often, we want to fail early so that we can correct our model. It's not pretty, it's not fun to find these things, but it's important, and you should actually view it as a really good thing, because it quickly helps us move towards a correct model. So these assertions document our assumptions, and they reduce the likelihood that errors will slip through. They reduce debugging time, and they help improve the thoroughness of tests. Okay, so we can quickly discover, for example, in a test when assumptions are off. So for example, if we have a model in AnyLogic where we have individuals associated with the coordinate x and y, we may ask, okay, is this a legal set of coordinates? Or did we accidentally create these people outside the legal area? Or did we somehow move them outside of it without checking? We want to make sure they're in the legal area? If so, we'll return a value for sort of where to find their information. So here we have an expression which only works if they're in a legal place, and we make use of that. Or we may want to confirm that something has been computed before we use it. Something is non-null before we go and we try to save it away somewhere. You know, we might do a computation, and we might check something we think is true, always true from the results of the computation. For example, make sure that we're not computing a neighbor that's in fact ourselves or something like that. So it turns out you can enable assertions in AnyLogic. Within the experiment, you can go to Advanced, and in the Properties, Advanced, and you can go to Java Virtual Machine Arguments, and you can do Enable Assertions. And if you can just put assertions down, it lets other people reading